This program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest UCTV programs.
I'd like to welcome you all here. This is a program that has been going on in the college for 17 years, since 1995. And one of the ongoing themes of the Critical Issues series has been the environment. When I looked back, I saw that we had 3 previous critical issue series on the environment. Just in 2009, 2010, Bill Freudenberg and Robert Wilkinson did 40 years after the big spill, looking back, looking ahead, 21st century environmental challenges in a global context. When you bookend that to the first one, which was in 1996, environmental issues and policy reform in America. So environment has been a very important part of this series, and it's very easy to see why. UCSB takes environmental issues very seriously. Part of our whole academic plan is to focus on areas of strength, and one of those areas is the work that we do not only in the sciences, but the social sciences and the humanities on the environment. And what we try to do in the Critical Issues series is select those topics and those faculty that are going to bring these together in very imaginative ways that bring not only students and faculty together, but especially policymakers and the interested public. And this is certainly one that kind of hit the headlines right at the right time. And it brings together people who have a genuine interest in this because, as you mentioned, Josh, we kind of perceive it now, and how we perceive it will have a lot to do with how we address it. So I look forward to being a participant in these discussions, and I thank all of you for coming, and welcome again.
Well, the prime organizer and coordinator of today's panel is Bruce Tiffany from the Department of Earth Science, and he will be the introducer and the moderator for the panel. Bruce.
Thank you, Josh. Let me first ask all of you, if you have one of these infernal devices, please turn it off or put it on silent. The focus of this, the first of our 3 sort of quarterly forums, is vulnerable communities. And to address this, we have assembled a panel of 3 separate speakers. Our lead speaker will be Professor Gary Griggs, who will provide a global context of sea level rise, coupled with a view that encompasses Santa Barbara, but also California and the West Coast as a whole. Immediately after his talk, we'll entertain a series of questions, and then we will have a break. After the break, we will hear 2 shorter presentations. First, by Mark Fisher on the effect of sea level rise on the campus, and the second by Ed Keller, who will look at sea level rise and patterns of erosion on the South Coast, Goleta to Carpinteria. In front of you, you should all find a 3x5 card. While there will be questions available after Gary's presentation, what we will do after the other 2 presentations is set up a panel up here, and we invite you, if a question raised by Gary did not get addressed in his sequence, or if you have questions raised by the other 2 speakers, to write those questions down on the card. And what we are going to do is collect those cards when we adjourn to create the panel, sort through them, and try to ensure that by looking at those that when we have the panel start its process, that it will address questions that are generally being raised. Because, of course, if I start picking questions, we don't know whether it's going to be a general question or a very specific one. The panel will proceed through a series of those questions, and then somewhere towards the end, 3:15-ish, 3:20-ish, we'll open back up for questions directly from the audience to cover other materials not addressed. We look to finish at approximately 3:45, and Leanne French from the Carsey-Wolf Center has arranged a particular tour at the Art Museum, which has a current exhibit on ruins and artistic perceptions, which includes some ruins created by water. She will give you further information at a slightly later date. But there will be an opportunity to join her to go to the Art Museum and view these. Okay, with that said, I would like to introduce Gary Griggs, who actually is a homecoming individual in this case because he got his undergraduate degree in the Department of Geology several decades ago, before going off to receive his PhD at the University of Oregon in 1968. And then he moved to the University of California at Santa Cruz, where he has been ever since in a variety of posts, and is currently serving as a distinguished professor and director of the Institute of Marine Sciences. His research focuses on the coastal zone, looking at coastal evolution, development, shoreline processes, hazards, engineering, and recently, sea level rise. And with the sea level rise, he has recently focused research on impacts of extreme events such as El Niños, coastal policies, and hazards arising therefrom. He recently, with a graduate student, co-authored Adapting to Sea Level Rise, a guide for California's coastal communities. A larger work through the National Academy of Sciences, Sea Level Rise for the Coasts of California, Oregon, and Washington, past, present, and future. And also a study that looked specifically at sea level rise and its influence on Santa Barbara. With that, I would invite Gary to come forward and speak. Well.
Thanks very much. It's an honor to be here to kick off this series and also to come back to Santa Barbara. I'm impressed with the interdisciplinary nature of this entire enterprise. It seems like it's the sort of thing we always talk about and never do. But as I looked at the number of people and departments and schools involved, it's really an amazing thing to put all these people together. So I hope this is a useful introduction, and it does include both a global view, but also looking more specifically at Santa Barbara. Is it going to be better to put the lights out? Yeah. Much better. So I always think it's important to make a personal connection to your audience. So, and in fact, I was telling an earlier story at lunch about an old friend and I who in 1961 or 62 rode a freight train from Santa Barbara to Berkeley for an all-Cal weekend, and it was nice to see Richard Sanford come to join the talk today. Thank you, Richard. So I actually came to UCSB 51 years ago. And it's been a wonderful career, and this was a great place to launch that from. But just wanted to put that in some kind of perspective, that after 50-some years looking at the coast, you do begin to make some observations. And there's a lot of different ways we can look at sea level, but one of the things I wanted to at least start with is the fact that there's very temporal differences. We've got short-term rates that are very fast. We can bring in a tsunami and raise sea level 10, 20, 30, 40, 50 feet over minutes. The tides come in and out every day, and depending on where we are, that can be tens of feet or more, but that's a very rapid change in sea level. Storm surges can go, as they did in New York recently, maybe 13, 14 feet. Katrina was 25 feet. We don't have that along the West Coast. And then there's long-term rates of change. During an El Niño event, sea level can rise a foot or two above normal for several months. We don't see that as a storm surge, but everything is higher than normal. And then we have long-term changes related to ice ages that can be responsible for over 100 meters or several hundreds of feet, and those take place over thousands of years. So per year, it's a few millimeters. So while we tend to recently think about whether it's 3.1 millimeters per year or 3.2 or how fast it's increasing, these are huge, very short-term processes that we don't want to forget about, because those are what are going to affect us in the short and intermediate term. There's also major geographic differences. Global differences in sea level are driven primarily by global temperature, and that affects both the volume of ice in ice caps and glaciers, primarily Antarctic and Greenland, as well as continental glaciers, and also ocean temperature. So as the ocean gets warmer, it expands, takes up more volume, and will raise sea level. So these are the two big drivers of long-term change. There's also regional values. Sea level is not the same everywhere for a number of reasons, but one of those is tectonics. Whether the land is in fact rising or sinking will affect what the regional rate will be. We've also got things like subsidence, where we're pumping out large volumes of oil or water. Whether it's Venice or Wilmington Beach, the land can be subsiding, which makes relative sea level rise even greater. And then there's all the atmospheric circulation, storm surge, El Niños that affect sea level again over the course of days or weeks or months. And just to give you summarize that briefly, this is from the National Research Council recent report on West Coast sea level rise. The two big players are ice melt, and as a result of that study, we feel this is now contributing about 2/3 of the total sea level rise signature globally, and the density changes from warming about 1/3. There's a number of other issues that we weighed. The more fresh water we store behind dams and reservoirs, that would tend to lower sea level, but the more groundwater we pump out that gets put on the land and goes into the ocean actually tends to raise sea level. Those are tough things to figure out. As best we could tell, those probably cancel each other out. And we've got, again, local uplift and subsidence the land. As ice is removed from the landscape, like Scandinavia and Alaska, the land will actually rebound, but there's some complications there. Those are not, however, the big players. These are the big players. So at any one particular place, we'll see a regional signal. Santa Barbara may not be the same as Seattle or London. Sea level rise varies regionally. And just to give you two extremes, if we look at Alaska over the last 60 or 70 years, sea level is dropping relative to the land. That's because Alaska is rebounding, having had the glacial ice removed. That huge load depressed Alaska. As that ice has melted over the last 18,000 years, the land has slowly rebounded. So even though sea level is rising globally a couple of millimeters a year, Alaska is rising much more rapidly. So here's sea level and here's the land. So the relative difference gives us an actual sea level drop. People in Alaska are not worried about sea level rise. They're worried about permafrost thawing and a few other things. Louisiana, on the other hand, is sinking, as are a number of places around the world. Venice is another. A mixture of groundwater withdrawal, the compaction of all that Mississippi Delta sediment and the subsidence. So even though the global rate of sea level rise over the last century was about 8 inches, if you look at Juneau, it's the equivalent of dropping 4 feet, and in Louisiana, rising 3 feet. So these are examples of regional differences that we're able to monitor. It was known for a long time, as soon as people started exploring the Earth, that climate varied from the poles to the equator. But it wasn't until the early part of the 1800s that people began to realize from some observations that, in fact, not only did climate vary regionally, but it also had changed over time. And it took perhaps 3 or 4 or 5 decades for some early people to figure out that most of that glaciation was driven by, or the ice ages, by variations in the Earth's orbit. And that is not a uniform pattern. There are 3 primary variations. One of these is the wobble of the Earth on its axis, which changes the amount of sunlight we might get. And that has a cycle, actually, several around 26,000 years. It's been called the precession. The Earth has a tilt on its axis, which gives us the seasons, and the actual amount of that tilt varies by 3 or so degrees, which takes the Earth a little further away and brings it a little closer. That has a cycle of about 41,000 years. And the Earth's orbit around the sun is not circular, but it's elliptical, so it can take the Earth further away or closer. So these in concert all determine how much solar energy or insolation the Earth receives. And those changes are catalysts for some feedback mechanisms that are relatively straightforward. But for example, as it starts to get warm, the Arctic ice starts to melt. There's less reflectivity. The ocean water begins to absorb more heat. Permafrost starts to thaw, gives off more methane and other gases, and that starts to push it. So we have a positive feedback mechanism, but it looks like these so-called Milankovitch cycles are the ones that push the large-scale changes in climate and therefore sea level. So if we go back in time, this is 0 today, 100,000 years ago, 200, 300. This is the path of sea level over time. So it goes between some pretty set ranges, and those are driven by these cycles between the Earth and the Sun, the Milankovitch cycles. Goes down as far as maybe 100, 125 meters and back up to 6, 8, 10 meters above the present. But these are all in the absence of human activity. So these are natural cycles. And you can see as the glacial cycles have come and gone, sea level has risen and fallen. So when it's warm, ice melts, sea level rises. During the glacial period, that seawater is sequestered on the continents as ice caps and glaciers, sea level drops on the order of maximum 120, 130 meters. So during the last ice age, we transferred about 3% of the oceans, about 10 million cubic miles of water to the continents as ice caps. Those began melting maybe 18,000 years ago. That went on up to the present. So here's where we are today. What's interesting, though, is what we call sea level today, or 0, is really a convention of today. If we would have been here 5,000 years ago, sea level would have been 40 meters below that. And I don't know about the anthropologists, the archaeologists, the historians, but there's been arguments put forward that until sea level rose to close to its present elevation and started to slow down 3 or 4, 5,000 years ago, it was very hard for civilizations to expand because most of the fertile land was on these coastal plains that kept getting inundated. So once sea level more or less stabilized, agriculture could become permanent and so forth. I don't know if that's been proven, but it certainly fits. This would have been a very hard time for civilization to develop along coastlines. Well, that, and it was a long time ago. So it's interesting to see this image was actually on the cover of the program. So if we go back about 18,000 years ago, the edge of the continental shelf was the coastline. So we take out 10 million cubic miles of seawater. We lower sea level 120 or so meters. This would have been the shoreline. Didn't quite go to the Channel Islands, and lots of interesting stories about mammoths getting out there and how far they had to swim and so forth. But this is where it was. So in the subsequent 18,000 years, sea level has advanced here about 5 miles or about 1.5 feet per year. So this again is in the absence of human activity. That's as the last ice age came to a close and those ice caps and glaciers melted. So it gives us some sort of long-term historical perspective of what's been going on before we arrived. This is trying to give you a sense of sea level over the last 300 or so years, or the last 200, and then projecting. So this is sort of the historic, prehistoric record when we're looking at things like tree rings, ice cores, sort of proxies for sea level and temperature. beginning sometime in the end of the 1800s, we began to put in tide gauges, and those are global, but they're also local, so that any one tide gauge will reflect what's happening at Santa Barbara or Santa Monica or San Francisco. But averaging those out, we find sea levels rising at about 1.7 millimeters per year. Beginning in 1993, we launched the first satellites that could measure sea surface from space through satellite altimetry. And measurements over the last 30 or so years show that that rate has nearly doubled. Now, how we can measure how fast the sea surface around the world is rising down to tenths of a millimeter from a satellite escapes me. But then I don't know how a cell phone works either. So, but these are consistent numbers. We have a lot of confidence in those. So this is sort of what we are measuring now with variations. And then we'll talk a bit about these. These are some of the projections for the future out to 2030, 2050, and 2100, using both some empiric relationships and also some models. If we look along the West Coast, these are all tide gauges. We actually have one at Santa Barbara, one out on Rincon Island, one of the oil platforms, Santa Monica, San Francisco, and so forth. This goes all the way up to through Oregon. So these are the rates, the averages, and sort of the deviation here, the spread from tide gauges. Some of these go back 150 years, some are 30, 40, 70, 80 years long. And you can see sort of these average values along almost the entire coast of California range between about 1 and 2 millimeters a year, just about the global average, which is sort of astounding if you think about how active the California coast is, that it's almost acting like a table over the last 100 years. Maybe Ed will have something to say about that of local tectonics. This begins to change at Cape Mendocino, and it's because most of California up to Cape Mendocino is characterized tectonically by the San Andreas Fault, sort of motion at the surface, or strike-slip motion. But once we go from Cape Mendocino north to Oregon, Northern California, Oregon, Washington, two plates are colliding. It's a transverse subduction zone where the coastline's sort of being warped up for the most part, so we get some negative rises, meaning the land is rising faster than sea level is rising. And this makes a big difference in what will happen in the future. I've been seeing these tsunami warning signs around Santa Cruz, or Santa Barbara. We have them in Santa Cruz too. This is the place where you don't have any warning. It's 20 miles offshore. Here we're going to have at least an hour and a half or two of warning. So keep your running shoes on. Santa Barbara does have a tide gauge down at the harbor. I tried to say this in a nice way. It's not particularly useful yet. And it's because it's been moved a couple of times. It's not sitting in the same place as the harbor was rebuilt. Recently, the West Coast numbers are sort of leveled off because there's some oscillations in the Pacific, but the deviation here is larger than the signal. So it's real hard to do a lot with the Santa Barbara tide gauge. We have to look on a more regional basis. But without question, as the seas are rising, coastal erosion will increase because the water's going to get, and the waves are going to get closer to the cliffs and the bluffs more frequently. This happens to be in Pacifica, north of San Francisco. By the way, these are for sale. Coastal damage from storms. This is in Capitola, where we've got restaurants and so forth virtually at sea level. And coastal flooding. This happens to be in Santa Cruz, where with high tides we now come across, this is without any more sea level. So during those extreme El Nino events with high tides, storm surge, and large waves, we're now inundating coastal roads. California state agencies have a major concern with sea level rise, and you can see whether it's Caltrans or Parks and Recreation or Coastal Commission. This is just from one state study that shows what a 1.4 meter rise in sea level would mean on top of a 100-year flood, where there are power plants within that zone of influence. We also have most of our sewage treatment plants because they're at the lowest part in the community, very close to sea level. And also at the local level. Sewage treatment plants, transmission lines, lift stations. Public Works is concerned with parking and roads, parks and rec, and future planning. What do we approve in the coastal zone? How far out do we look for hazards? So Bruce mentioned 3 studies. This was one we did for the state in addition to doing a guide for all coastal communities, we picked one community to work with. So we worked with the city of Santa Barbara to do a sea level rise vulnerability assessment. How vulnerable is Santa Barbara? This was the guide which was meant for any coastal community. It sort of walks you through what's involved in hazard assessment, vulnerabilities, how do you begin to pull those pieces together. And then the NRC committee I was part of that just released this report in June, which was a West Coast wide study to try to give state agencies and local agencies the best information we could provide on what to expect in the future. So just to start out with the major findings of that report, are averages, and for each year into the future, there's a range of projections, and I'll explain why. If you just remember 6, 12, and 36. These are in inches. So by 2030, our sort of midpoint of sea level for the California coast would be 6 inches of rise. So that's only 18 years away. The last century was 8 inches for the entire century. So this is an acceleration. By 2050, the midpoint is about 12, and by 2100, about 36 inches. As I just said, as sea level rises, it'll cause waves to reach further inland and higher elevations. To prepare for the immediate future, we need to look at these past extreme events, not just whether the rate of rise is 6 inches or 7 inches or 8 inches, but what happens when we have these large El Nino events? Those are the things that are going to hit us the hardest in the next several decades at least. And along with cliff or bluff erosion, flooding followed by more permanent inundation is going to increase along with the exposure to those waves. So how do we make the projections? Well, the IPCC, which probably most of you have heard about, their last report was released in 2007, and that included data up to 2006. So our NRC report updated that by 6 more years of data. So their projections are based on global climate models, and there's a number of different models that weigh different parameters differently. They also include different development and greenhouse gas emission scenarios. So there's a wide range in what those values might be depending on what you assume about what's going to happen in this country with carbon emissions. How about China? How about India? Those are big ranges. So we cannot come down unless we make some real clear assumption about what we're going to be doing in 2100 with a specific value. But these models underestimate land ice contributions, which we think now is the most important factor. Over the last decade or so, 2 other individuals, Vermeer and Rahmstorf, have been putting together a semi-empirical method, and what they've done is gone back into the past, looked at global temperatures or proxies for global temperatures, and where sea level was at that time in the past, and showed a very good relationship. So what this does is eliminate these models where we've got to measure ocean temperature and assume which depths increase in volume by how much because of temperature, all the ice contributions and so forth. This just looks at a clear semi-empirical relationship between overall global temperature and sea level. It reproduces past sea level well, but its ice behavior is now changing more rapidly. And then what we did with the NRC report, which was to actually account for those rapid changes in ice sheet dynamics. So this initially could look like a lot of information, and I will take credit for this because the initial report has various lines of sea level with different models, and I said, let's make it simpler. So this is pretty simple, isn't it? Blue, yellow, red, green. So this is 2030, 2050, 2100. And in each case, this is Oregon and Washington because it's a different tectonic regime. You can forget about Oregon and Washington unless you own beachfront property. California are global numbers, and then this is Vermeer and Ramsdorff. So these are the two important ones, and actually yellow is the important one to think about. So this tells you down here in centimeters what we think the average point is in the range that California might see statewide up to Cape Mendocino at those 3 periods. So just to put that into simple units, 6 inches is the midpoint, but it could be from 2 to 12 inches. By 2050, 12 inches was the midpoint. It could vary from 5 to 24 inches. And by 2100, the midpoint is 36 inches, but it go from 16 to 5.5 feet. And I guess, again, I just want to reiterate, how do you project out to the year 2100 when we don't know what the greenhouse gas emissions are going to be because we don't know how the global energy economy will go? It's sort of like if you have a 15-year-old and you're trying to plan for their college expenses today, that's not too bad. 2 or 3 years, the tuition UC will probably triple. But if you have kids that are 2 or 3 years old and you're trying to project what it's going to cost them to go to college in 15 years, what's your error bar? But what if they're going to go to college in 80 years? Or retirement. How much do you need today if you're going to retire in 2 or 3 years? You can probably figure that out. But if you're going to retire in 2100, so these have big error bars. I won't apologize because we don't know the global carbon economy. So the uncertainties in part are that the regional projections are harder than global because there's more factors involved. And some of those uncertainties get greater as we go further out in time. We don't completely understand the climate system. There's a lot of different people doing a lot of different global climate models. And they all involve assumptions about what the greenhouse gas emissions will be in the future. One of my favorite climatologists, I'm sure you've all read that quote. That's a great quote. It's a great quote. There's also another one I like. Tell me what you know, tell me what you don't know, then tell me what you think and distinguish between them. So in our NRC report, we tried to say, here's the things we're sure about, here's the things we're not sure about. So the certainty is we feel pretty good about 2030. That's only 18 years out. 2050, perhaps. By 2100, we're only confident that it'll fall within that range. But that's a big range nonetheless. So to put this now, that global long-term picture into a shorter-term picture, this is the tide gauge for San Francisco that goes back to the 1850s. There's sort of a hiccup here with the 1906 earthquake, but in general, it shows about 2 millimeters per year. These are El Nino events. Ones you may remember, probably not that one, but certainly 82, 83, 97, 98. So during those events, for example, sea level rose about 11 inches, or 288 millimeters, for 2 or 3 months. 11 inches, 82, 83, 12 inches, a foot. And if we project out into the future now, how long will it take global sea level rise to get to that point? Well, if it's only rising at this rate, 2 millimeters a year, to get that high, to reach what we reached in these last El Niños, it would take 140 years to equal what we've had happen during an El Nino. However, we're already globally rising faster than that. If globally sea level rise at 4 millimeters a year, it'll only take 70 years to get to that point. And if it rises at 8 millimeters per year, it'll be there this quickly. All I'm trying to say is these events are going to be more important in the short term than a couple of millimeters per year sea level rise. It'll take a long time till this curve catches up with those short-term events. Is that clear? Okay. So these extreme coastal storms, these big El Nino events, have caused most of the coastal storm damage, whether it's waves impacting structures. In 82, 83, something like $200 million in 2011 dollars. This is the picture I started with, the Santa Barbara Yacht Club. I was down there today. There's a nice wide beach out in front of it. And water levels, again, can be higher during these events to at least 2030, possibly 2050. But they're going to become additive because everything is on a ramp. And this is a way we could, I guess, look at Hurricane Sandy. The higher sea level is every year, the more those hurricanes are going to inundate and flood further inland. So that may not be the reason that hurricane occurred, just like steroids may not have been the reason Barry Bonds hit so many home runs, but it probably didn't hurt. I could add Lance Armstrong, but I won't. So these are the kinds of things we see during those large events. Again, short term, this is Mission Beach in San Diego, and this is when most property gets sold. But during '88, again, this is the beach, and these people are living quite close to sea level. So during '88, this is actually right here, and the person's standing right there. A large storm with a high tide in 1988 came over the wall and into all these structures. So areas that otherwise look very stable and safe are quite low along much of Southern California's coast. This is Ledbetter in the '83 El Nino, looking from up coast and down coast. Cabrillo Boulevard, 1983. Waves came all the way through the park out onto Cabrillo Boulevard. I wasn't here in 1914. But this is Cabrillo Boulevard in 1914 during a major storm. So it has happened in the past, and those records are there to sort of go back and remind ourselves. And I don't know if this was an El Nino year or not. I suspect it probably was. Newport Beach is some of California's priciest real estate, all quite close to sea level. This parking lot, this is the summer of 2010, waves overtopped the wall, came into Newport Beach in the summer months. Cliff erosion, again, you all know Shoreline Park. I think Ed may show this. I'm not going to take his thunder, but these cliffs are not in the best geologic situation with dip slopes, the bedding dipping into the water, but landslides have taken place there. If we look at the mesa, sometimes probably saying nothing is better than saying something. Maybe this is just a little guest house. But one of the things we did in our Santa Barbara sea level rise vulnerability assessment was to look at the homes on the mesa to see how fast. We didn't look at the erosion rates. I'll show you the next slide. But this was 8 homes were within 50 feet of the cliff edge. Within 50 to 75 feet were another 17 homes, and within 75 to 100 feet with another. So there's quite a few homes that are close to the bluff edge. How we will begin to deal with those, and this raised the issue of seawalls and armor and so forth. The city does have a map that's on its side, which wasn't supposed to happen that way. This is a map that's been used in their general plan, and it's a firm who actually used some models to project erosion rates inland by 2030, 2050, and 2100. And I'm not going to hold this up here for a long time because I didn't do this, but it's one method of projecting. This would be Ledbetter and City College and so forth. But this is the bluff edge, projecting erosion into the future if things keep going. When we were doing the city plan, I knew about the cemetery and the Clark estate, and I said, I wonder if there's problems here. The people in the city said, well, no, we haven't heard of any. So I said, I'm just going to find out. So I called the cemetery. He said, yeah, we're moving gravesites back. So there has been riprap and protection, but I mean, this isn't what you'd call high-end homes. Well, I guess it's I'm sorry. That was sort of inappropriate. Long-term homes. Isla Vista, having lived in Isla Vista for some time, I have an appreciation for this area. But what can you say? A lot of apartments probably have been paid for many times over. Things, are getting closer and closer to the edge. And finally, this one, which was undercut, was finally declared unsafe to occupy. And part of it was removed. But they're still building cliffside homes in Isla Vista. This is now a little old because of Al Gore, but sea level doesn't have to rise 20 feet to become a problem. It can be 2 feet or 3 feet or 4 feet. This is the Embarcadero in San Francisco at a high tide today, and that's some pretty valuable real estate. maybe not Manhattan, but close. This is a study that's gotten a lot of recognition, and it's San Francisco International Airport with a 16-inch rise in sea level. So all the blue, these are the runways, this is 101, would be inundated or covered with 16 inches in sea level. And you might say, well, why did they do that? Well, this was all built on fill, and at the time they built this back in the 50s, they were not thinking about sea level rise. It's a lot of money and investment to do a fill that large. They got it a couple feet above sea level and said, fine. But the next time you land or take off from here, look at the edge there and how close San Francisco Bay is to the edge of the runway. So you might say, oh, okay, I'll use Oakland. It turns out Oakland looks exactly the same because it was also built on fill. So there are some options. I would say this isn't one of them. Those are huge infrastructure projects, and while we're talking about Sandy and Manhattan and so forth, New York isn't alone. There's a lot of cities around the world, some of the biggest cities that aren't that high above sea level. I'm not going to pick on Santa Barbara. This is the old terminal in 1969. You can tell by the age of the cars. It was a little island. 1995, that's water on the runway. So the Santa Barbara Airport was built on an old slough. It was elevated a bit. I'm going to show this really quickly, then I'm going to move on. No, I'll go back to it. So when we were working with the city on the sea level vulnerability assessment, I was surprised to find that the airport is actually part of the city of Santa Barbara. It's not Santa Barbara County. So this was a very generalized map, and we're coming down to this topic of figuring sea level. That includes the 100-year flood today in light blue, and the 100-year flood plus 1.5 meters of sea level rise in the dark blue. But one of the problems of doing a map like this is, first, you depreciate all the property really quickly. But second, unless you have a really accurate topographic map, these are sort of meaningless. So this goes clear up to the high school. I don't think that's going to happen. But you need to have a map that has better than a 5-foot contour interval. And I don't think we probably have that control. This is the airport. I know the airport terminal has been elevated, and I've heard today that maybe the runways have been elevated. But this is also clearly, it's not SFO, but it lets you know how low-lying that area is that you kind of drive by and look at every day. Did anybody recognize this? Quite oddly, I was in Italy in June and staying in this old villa with a family that was quite wealthy who had traveled extensively in the U.S. in the first part of the last century. And they rent this villa out, and they have all their library and books and these old photo albums. They left for people who stay there, and I pull open this photo album. And they traveled through the U.S., or the western states, in 1904. And there was a whole series of images from Santa Barbara. So this is standing. This is Ledbetter. So this is looking from about where the end of the breakwater is, up coast. So this is probably, well, anyway, this is all now, well, I'll turn it around. So I think there used to be a wharf here, and I think they were standing on that wharf looking up the coast at this area. So the harbor began construction in 1928, 29, and as you know, sand began to fill. That photo, I think, was taken probably from about here. By 1934, it had built out to here. So that whole area where all of the harbor facilities, the yacht club, Santa Barbara City College Stadium, all the park and parking lot are on old seafloor, beach elevation. And that's why they're probably light blue in that image. So if you look at that area today, there's the shoreline where it was. So depends. The sea level rises 1 foot, 2 foot, 3 foot, 4 foot, 5 foot. But this is probably, I'm not trying to scare anybody, just try to give you some idea because we're figuring sea level rise. How do you figure that because I do a lot of coastal work, I'm always amazed at what people name things. This is actually down in Malibu, and I've been doing some work down there on Broad Beach, which is an area where a lot of the movie people live. They have some serious problems. They live on the beach. Their septic tanks are between their houses and the shoreline, and the shoreline is eroding. So they started with sandbags, and now there's rocks. But you'd think with a structure like that, that would probably be the first one to go. But I was just down there 3 months ago. They've actually decided to save it, but in order to save it, they can't tear down the old house. So they've actually put down concrete caissons. They're going to pour concrete grade beams, and they're saving the walls of the old house so they can just build this around them. So how you own the water, I don't know. But this is not what I would call moving back. So a few other images. And again, I just threw these out because these are the things I work with. I'm not sure which give you an impression that is more meaningful than others. This is actually Miami, but this is all less than 1 meter above sea level. I think the highest point in Florida is about, how much? 330 feet. It's sort of a big tilted shelf. But this is what Miami looks like when you're flying in. So that's all less than 3 feet above sea level or close to it. So Manhattan does have problems, but so does Miami. The Mississippi Delta, New Orleans, this is the present shoreline if we raise sea level 3 feet. Bangladesh is only different in that it's also low, but there are hundreds of millions or tens of millions of people already living on sort of mud islands that come and go as sea level rises and falls. The South Pacific Islands are known quite well. This is sort of high tide, places that were only a few feet above sea level to begin with. So there, the difference between 36 inches and 5 feet is huge, whereas if we're living on a sea cliff, where most of UCSB is, it's a very different story. Another way of animating this is part of Japan, Korea, China with 1 meter, 2 meters, and 3 meters. Now, or 6 meters. These are big numbers, but it gives you an idea sort of what's out there, as well as Northern Europe, England with 1 meter sea level rise, which could occur by the late part of the century, 2 meters and 3 meters. So there's a lot of different ways people have begun to visualize this. I used this before, but I thought of a better way to do it recently. So this is the low, medium, high for 2030. I just picked a person for scale. This is low, medium, high for 2050. And 2100, this gets a little messy here. So I knew this would be an entirely democratic group, so I thought I'd get away with that. So this, to me, probably is more meaningful than showing you that yellow bar. So I'm, again, trying to think of ways. I couldn't get the shark off there this morning, but. So adapting or responding to sea level rise. Somebody has proposed a $6 billion system for Manhattan, New York City, and there's all kinds of questions already about, well, who gets to be protected and who doesn't. London has something like that now on the Thames. Venice has some flood walls. But this begins to raise the question of what do you try to protect? What can't you protect? How many are there? How many other cities are there, whether it's the San Francisco airport or Miami or London or Shanghai, that have very similar problems? How high can you build the wall? Because everything doesn't stop at 2100. We can say it's 3 feet or 4 feet or 5 feet, but it's going to keep going. So how far out do we look? And that depends on what it is. Is it a parking lot or a park, or is it a city? There's the King Canute approach, where this is a long story, but basically his surrounding people were always telling him how powerful and how great he was, and he tried to sort of finally tell them that that wasn't the case. So he said, "Can I stop the ocean from rising?" And they said, "Yes, you can, my lord." And so they put him out here, and he said, "Stop," and it didn't stop. So he tried to humiliate them. North Carolina, you may have read. It's on the Colbert Show. after their commission gave them a predicted level of 39 inches by 2100, the business and development people objected, said it would cost them too much money and it would restrict development. So they basically passed legislation and said, for the time being, we're not going to let you use an acceleration. You've got to use everything that happened during the last century. That's like sort of saying, well, don't worry about hurricanes. What the weather was like the last week is all you can use for the next 50 years. And this is North Carolina recently. Virginia did something only, I don't know. They thought of sea level rise as a left-wing term, so they excised it from a state report and called it coastal flooding. They definitely have coastal flooding. And then the Virginia Sea Grant Program actually has another statement that well, we lost that. Basically, Virginia Sea Grant says, you know, we're one of the most sea level rise prone areas on the East Coast, and we better start doing something about it. So there's a conflict within the scientists and the legislatures, which isn't a new thing. I'll just throw this out there. Here's another way, but we have a few too many people for that. So things I want to leave you with again is here's some values for sea level rise for California. Generally, 6 inches, 12 inches, 36 inches. That the biggest threat in the next several decades at least will be the confluence of El Nino events and high tides and storm surges. But we're on this ramp of an increasing slope so that each year the sea level rise is going to magnify the effects of those storms on the coast. So we're going to see both coastal erosion rates of cliffs, bluffs, dunes increase, as well as more flooding and inundation. And the last thing I'll leave you with, John Holdren is a science advisor to the president. He said basically we have three choices: mitigation, adaptation, and suffering. We're already doing some of each. The only question is going to be what the mix will be. The more mitigation, the more greenhouse gas reduction, the less adaptation and less suffering will be required. Thank you.
Okay, in opening this, the second half of this undertaking, let me first note that the publications that Gary has authored on both Santa Barbara and on the West Coast in California, links to those are going to be available on the Critical Issues website for this year, so if you wish to track these down, you may. We are also being videotaped so that if you missed something or if one of your colleagues had to go away, as two of mine did for child care duties, you can track down the rest on a video, tell your friends. Finally, I will fill in a hole. We want to owe a vote of thanks to the Bren School for offering this space and hosting this particular meeting. And indeed, thank you to the Bren School and its management. Right. It's now my pleasure to introduce Mark Fisher, who is the Senior Associate Vice Chancellor of Administrative Services and our campus architect. He comes with a Master of Architecture from the University of Pennsylvania and is a member of the American Institute of Architects. He came to UCSB 10 years ago from UCLA, where he was the campus architect, and his is the headache that comes if sea level does rise, because he is responsible for campus planning, design, construction, housing and residential services, transportation, parking services, and in essence, the infrastructure on which the rest of our mission depends. Mark.
Thank you. Am I turned on? Is this a lavalier? Oh, there we go. Of course, we all know the campus is a beautiful piece of real estate. Luckily, we are high in terms of topography and the level of the sea as it exists today, at least. I'm going to go through a series of slides here that begin to address some of the issues that we've been worried about and how we think we might, I think the right term is adapt to them. First of all, this was an article that was in the New York Times, September 10th this year. And basically in this article, the mayor was complimented for thinking about sea level rise, but criticized for not acting on sea level rise. And so with this article, this is a wake-up call to people like me, people involved in policy or dealing with infrastructure, that maybe we need to be thinking about this for the campus, because what impacts New York impacts us. Of course, this is an amazingly timely article given what's happened there in the last 2 weeks. So very prescient. At the same time, the Chronicle of Higher Education, the exact same day, had an article that said that campuses need to be aware of this, and also basically said, you campus administrators have your collective heads in the sand, you're not really dealing with this. And so with these two articles, and Janet's coming to talk to me about how the campus might be involved in thinking about sea level rise, it certainly brings this to the forefront of my thinking and what we might be doing here to prepare for the inevitability of sea level rise and the impact on the campus. Just as a reminder, the campus was long history, Shumash site, either a village or a place the Shumash were infinitely involved in, and then became a farm, and then later a military base and marine base. The pattern, though, of land, the slough, which lagoon is something we all love very much. It's here over the long term. It's had a different condition over time. I'll talk about that a little bit later in terms of what the sea might do to that. And of course, the Goleta Slough has been changed over time. The island has been chopped away to build the sewer plant. The airport's in here now. Obviously, the airport's right in where the waterway used to be. And we know longer history that this was supposedly navigable. And then just some images of the campus as it evolved. And I think the only important thing again here is the landform is still largely the same. You do see over time the beach changes shape along the east side of the bluffs. At this point, while the military base was here, the marine base, the beach was a little bit wider. There are pictures later in the 60s and 70s where the beach is way out in here, and there are volleyball courts set up down here. So it had really been a developed part of the campus landscape. Otherwise, the lagoon is here, changes shape. Sometimes it's more of a mud flat, and as it is in this picture, and other times, top of that. And then at other times it has been partially filled with water. And then the current condition today. As a reminder, we're 1,055 acres. Most of us think of the campus as roughly 400 acres on the east side, the core or main campus. There's also the Stork campus, where we have some of our probably greatest vulnerability, where there's a finger of the Goleta Slough. And then, of course, the far west side of campus, where the Devereaux Slough comes in, and the north campus, where we've just built some faculty housing. And I'll talk a little bit about vulnerability over there and some things we've done recently. But largely, the campus is high, above the Pacific. Of course, we surround the community of Isla Vista. We have all the edge conditions we need to worry about in terms of erosion. But just in terms of basic sea level rise, if you didn't worry about other things, we're probably okay. This map, which is probably a little harder to read than I thought, tries to show what a sea level rise of 10 feet, this is 0 to 10 feet in the yellow-orange color, would do to the campus where water might be. And then it goes up in 10-foot increments. So as the colors become richer, you're moving up at 10 foot. So what it tells me, at least, is we're vulnerable along the edge, maybe at the 217 at a 20-foot wave, or if the sea were to rise to that level, vulnerable along edges of the Devereaux Slough, possibly into the old golf course in here. The fellow who manages the golf course says is the fairways there at about plus 8 feet, and the greens are at plus 14 feet above sea level. This map shows everything beyond 10 feet, so it's a little higher here than perhaps they think it is. Again, vulnerability, though, along this back edge. This is Los Caneros Road coming through. Stork Road would be here. So this finger of the former Devereaux Slough, or the extension of the Devereaux Slough, is probably our greatest area of vulnerability. The core campus is between 30 and 40 feet above sea level. Isla Vista between 30 and 40 feet above sea level. And we're as high as probably 80 feet above sea level out where the oil tanks are at the very, very west edge of the campus. So again, most of the campus ground is well above sea level, well above predicted sea level heights. Still, the entrance points, 217, Los Caneros, and Stork Road, are really vulnerable. So we become more of an island if we do start to see sea level rise that impact those points of entry to the campus. We're in the middle of a big planning process, so we pulled together these images. This is our master plans drafted in 2003, and it just, again, shows that vulnerability is largely at the edges, the north edge of the campus, and it doesn't really impact the planning or thinking on the campus itself, the core campus. Again, a little bit of an impact in around that finger through the historic campus, and this blows that up. You can see that sea level rise, there are a series of sort of floodways and gates that allow seawater or floodwater to flow into these areas and back out again. We definitely need to be mindful of the edges of those areas and what that might mean for that development in those areas. We have already started to think about the old Stork family housing site, which is right here. This is, again, as I show you, I'm terrible with giving directions, but Los Caneros Road is this. This is El Colegio, Santa Catalina, or San Clemente housing in here, Santa Catalina here. We've thought about changing the elevation of this area. It's in the 100-year floodplain now. That's a different issue than the sea level rise, so we're already thinking about how you might modify the topography to handle the issues of storm water. Okay, so increased storm damage. Following on the prior talk, this is really probably as big an issue as the issue of sea level rise. Of course, stormwater damage and stormwater impact becomes increased when the sea doesn't allow the water to slip back out. You've all seen things like this on the campus. You know that when we have storms, they're pretty impactful. This is one of the large eucalyptus trees roughly west of the physics building, falling on one of the old trailers back there, since removed. Similar slides as earlier, the airport underwater. And again, a little bit different image, but the airport underwater in the 60s. In the same slide you saw before. So, we've seen these storms where you have high levels of rain over short periods of time. They're not frequent, but when they happen, they have a huge impact on us because we're at the bottom of the watershed. So all of these creeks that flow down out of the hills come down into the area around the airport and the campus. Now, this was a map that was created after some of the recent fires that showed potential flooding from the fires, but probably more important than what's red are the areas that are red and or blue. The blue areas are also prone to flooding. You can see that this weaves its way up into our north campus where we've just built faculty housing. It weaves its way into Stork and San Ynez housing on the Stork campus. And so we need, again, to be very mindful of these areas. One of the things we did in this part of campus is we actually raised the topography as we built faculty housing. Are any faculty members in here who live at North Campus? No. Anyway, when we built the housing out there, the first 22 units, we raised the earth. I think it's about 24 inches. We widened the creek, working with the Coast Commission and Seaber, so we've laid back the creek edges. It's transformed the cross section so more water can flow out. And in fact, the FEMA map has now changed so the floodplain doesn't go that far in. That's a short-term solution, though, because as the conditions change off campus and in the sea, clearly I think those floodplains will rise as well, and we'll need to keep thinking about how we manage that. And then just another reminder of what can happen. This is looking eastward toward the 217. If you're standing out on the north bluff on the campus, the airport's over here, Hope Ranch in the background. That's an everyday condition. This is 1995. This is the water coming up very close to the road. And I believe during this storm, they either closed the campus on the east gate, or at least were anticipating closing the gate. It predates my time here. But again, a place of real vulnerability for us in a major storm event, or if there is the impact of additional sea level rise. So something as planners on the campus we clearly have to be worried about in terms of the future on this campus. And I know that Ed's going to talk about this, and I won't dwell on it, but we also are impacted by what happens with bluff erosion. We know that it erodes at about 1 foot per year. The tricky thing with that is it's never an even 1 foot that you can plan for. It tends to fall in bigger chunks. So it's 5 or 10 feet. And so the same condition that happens here in the slide in Isla Vista, we're prone to this also all along the east side of the campus. This is Anacapa Hall, which you can see is very close to the road, which you can see is very close to the bluff. And if you go out there today, you'll see that there are 2 or 3 fences. We keep moving this fence back to protect pedestrians from falling over the bluff, which has happened in the past. And this is probably the thing I most worry about, is what happens when we lose the edge and the road begins to go. And then the next thing is what happens when we start to lose the building. Managed retreat is something that has been talked about a lot at Goleta Beach, just around the corner. It's difficult to think about managed retreat when you have this much invested in a piece of property. We have billions of dollars of capital improvements here, and at some point we're going to want to talk about how do you protect this. And I know it's a very complicated discussion because of what it does along the entire coast. And or, as a campus, we start to think about demolition of pieces of buildings like this, and we do allow managed retreat. And in our master plan, actually, we show a new roadway that cuts through here that was developed specifically because we were afraid we would lose this roadway, and we needed to start to plan for what the new roadway might look like. So we've definitely jumped ahead in this to think about what happens in the very worst case. I'd like to think that there are steps along the way that might protect assets such as this so that we don't lose them, but we are thinking ahead in terms of if we can't protect the assets. And that's my piece, so. Yes.
It's a real pleasure being here this afternoon. Being a geologist, I'm also in the environmental studies program, and in fact, most of my appointment is in environmental studies. And by being in that department, I've become more aware over the years of working with social scientists and humanists, a kind of a broader approach to environmental things than I'd had before. And so rather than dwell on rates of everything, we know our rates of coastal erosion at UCSB are pretty high. Actually, they're about 3 inches a year. Art Sylvester, I don't know, is Art here? He said he may come. He's been measuring these faithfully for about 11 years along the fence post, and it averages about 3 inches a year. It is as great as 1 foot in some places, and sometimes you have to figure out, well, maybe if it's 1 foot, that's where it continues, we'll have a problem. We will have a problem, there's no question about that. But more than dealing with, how fast sea level is going to rise, we know it's going to rise. We have projections and measurements, or how fast the erosion is going to be. A really big issue in this whole thing is going to be really science and values, and that's kind of what I wanted to talk about with some of the slides that I'll show. If I can figure out this thing here, I guess the middle one changes it. Okay. Okay. This is our coastline, or part of it. It's not the whole thing, of course. And Isla Vista's out here, UCSB is here, down to Rincon Point and so forth. We have a long stretch of coastline. And our coastline is our golden goose, so to speak. Lays the golden eggs. We're a big tourist area. People come here because of our beaches. And so we're in a quandary, as many people around the country are today, is do we want to maintain the beaches for people to enjoy, or do we want to defend them to the point that they'll be highly degraded? That's an important question. Or if we're going to do some mixture, where do we decide? Do we save Isla Vista? Or Hope Ranch, or Rincon Point, or what about Carpinteria, Montecito? We don't have enough money to armor the whole coastline. And even if we could, you could ask the question, do we want to? Okay? A few years ago, there was a big controversy over Goleta Beach down here, as you're all well aware. And I went to a meeting there, and I was on the advisory committee. And they told me I couldn't make any value judgments. I was a scientist. I was there just to give them the science. And it wasn't in my privy to talk about whether I preferred sand crabs on the beach and natural sand on the beach, or a complete line of rocks protecting the beach. I've changed a little bit my ideas in recent years because of climate change. We're fairly certain that sea levels are going to rise a couple feet by the end of the century. If we were capable or able to really slow our carbon emissions, they say we could slow the actual rate of temperature increase by about 2 degrees, so maybe we'd be on the short end of this other thing. But bear in mind, every time sea level rises, the rates of coastal erosion go up faster, okay, because you're putting more stress on that environment. So our stretch of coastline is important to us. It's important for a lot of reasons. And one of them is our tourism, the beauty of the coastline. And so I always tell people, make a values clarification. Where do your values lie? And from there, you can ask scientists, okay, what are our choices? What are the list of choices do we have? But the first thing, you have to have your values clear, or science really can't help you. So I think the first thing we need to do in thinking about what to do on the campus, what to do in town, what to do along our coast, is to have a really soul-searching exercise and draw up some priorities and values. And then we can decide where we're going to spend limited amounts of money and how we're going to go about it. You've seen this one, but as sea level rises, it puts stress on the shorelines, and the shoreline will shift more than the sea level rise. So we're going to be heading for problems around the world with this. Some people are already facing these problems, and islands are disappearing from water seeping up from within. Big waves has happened in the 80s. This is along part of the sea cliff. And this is a good idea to look at this. I agree with Gary on that. Look at these past big storms where really big waves hit our coastline and see what was going on there, how high was sea level, what can we expect at various places. I remember when I first came here, we had a storm, I think in the 70s or 80s, and one of my friends was a surfer, and he caught a wave at Campus Point and rode it past the pier, one wave. And he came in with his surfboard in hand and said, "I'm not going back out ever again." And I was watching people on the pier. They were out at the far end, and the big waves were rolling in, and the foam was right about the height of the pier, and they were just jumping up and down, like this, and the pier would go like this. And I finally went out, and I said, "Thank you, she ought to go think about going in." But so we have cases in the past where we've had some sea level rise. So we can deal with that aspect, at least get a model of what's likely to happen and where the vulnerabilities will be. We know we're vulnerable to tsunami, and we've had tsunamis in the past that have gone up all the way to Highway 101 down in the city in 1812. One of my former students, Tom Rockwell, and some other people are testing the idea that maybe even bigger tsunamis have occurred here in the past. And we know that because bits of our coastline have been suddenly uplifted by 10, 15, 20 feet during earthquakes. I'm not a proponent of that till we find the deposits, but we're searching for them in Carpinteria Slough and some other places. Some houses actually have been destroyed in Santa Barbara by high waves. This is again down by Sea Cliff, and big rocks went right through this house during those storms. And now I was shocked when they rebuilt it, but they did. They almost always people will rebuild if they have the permit. And now they've got this situation where this is open and that's open, so big rocks can just roll through. Which isn't a bad thing to do. They do that in hurricane country all the time. And when they have the big storms, it just goes right under the house. And that's but that's a pretty precarious spot. Isla Vista, of course, the poster child for coastal erosion. These houses weren't built this close to the coast. They were built back actually pretty far. But the rate of coastal erosion in Isla Vista is closer to a foot a year, according to Bob Norris, who studied this a number of years ago. So what are our value judgments here? When do we decide to tear out houses and build a park along the top? I've had a plan for Isla Vista for years. No one ever listens to me, but that's okay. And that is to get rid of all the houses along the front, build some parking structures in behind, get all the cars off the road, and just have a place at the town for people, and have the whole coast be the park. And then people can move their stuff to wherever their houses are with some sort of transport, but get the cars off that place. But anyway, that's a different matter. But these things won't be with us forever, these houses here, obviously. And some have been moved, and more will have to be moved. And, Isla Vista's not the only people who have made some kind of interesting decisions. Our marine science building's about 15 feet from the edge. And when they built that, I couldn't believe it. I absolutely couldn't believe it. I said, what are we building this building so close to the sea cliff? And there it sits. And someday we're going to spend a lot of money to defend it, depending upon, again, our values. And I think we value that building. The same could be said for a number of other buildings. Sea cliff erosion is insidious and will continue going on. And I'm glad we're planning down the road for it and making these kinds of value judgments. We didn't know so much about the rates, even when that building was constructed. So we've got this little bit of UCSB. We've seen this one. This is an interesting little thing. This is our place where all the surfers go and hang out. And they ride in. This little bit of rock here is probably an earthquake that uplifted a bit of the seafloor, and you can see even a bit of it down by Goleta Beach. Even has some paleo tide pools in it. And we estimate it was probably a 7.5 earthquake. If a 7.5 earthquake occurs in the channel, we will have small tsunamis. And if it's in an El Nino year and it's at high tide, we could be talking about 8 feet rise, and we might become an island for a few hours or a few days. But all of our tectonics plays into some of this. I think the Campus Lagoon actually was a stream that flowed into Goleta Slough back here. Actually flowed that way, and the headwaters have been eroded off. This whole surface slopes back that way. It's part of a syncline. I don't want to get into the geology that much. Goleta Beach looks nice much of the time, and we've done a lot of beach nourishment there. Goleta Beach is not a natural beach, okay? It's several feet higher than it would have been. The military had it, they filled it, and when this erodes, sometimes there's an old dump there with really interesting, like 1922 Coke bottles and things in there. And also the beds are highly contorted, and from liquefaction, I think, in the 1925 earthquake. So anyway, we built this up. It was a sand spit that regularly overwashed all along the whole thing. And so when people talk about Goleta Beach as being natural, it's very, very far from a natural beach. But that doesn't mean we don't love it and we don't want to keep it. And maybe our values will suggest, as some did during that meeting when they told me to leave, that every blade of grass, they didn't really, but almost, every blade of grass is precious, and we can't give any of it up. Versus other people were saying, well, you know, I kind of like going out in the summer in a moonlit night and watching some grunion run and doing some other things on the beaches. And we know if we build a hard structure, we're messing with the system. It may work for a while when there's sand that comes through, and it may eventually erode to a much narrower beach. I'm a fan of the latter eventually, and because I've seen the evidence for it. If you go down to a steep beach with a big rock revetment like the Santa Barbara Harbor, there is no beach. The reason it keeps the sand is all moving there, but no sand accumulates. Along our coast, we see signs of erosion. This is one of my favorite beaches, Arroyo Burro, little wave-cut notches. If sea level rises, this will accentuate. Sometimes these form into sea claves, and this will eventually fall down, and the whole thing erodes in a kind of sporadic way. And this, we talked about, I think Gary talked about Shoreline Park. I've been there for quite a long time working. I have a house near there. This is the wave-cut platform, a bedrock in the sea cliff, and that's eroding down there a few inches a year as well. What's interesting at Shoreline Park is this orientation of the rocks. There's a lot of landslides. Every little curve here is a landslide. Every single one. And I remember, we don't have a lot of collective knowledge in our parks, unfortunately. They're great people and they do great things, but the collective knowledge isn't that great. And I asked him one time, well, why do you think this fence is so wavy along the front? Do you think whoever did it was just drunk or something when they put the fence in? And we finally came to the conclusion that indeed the fence has moved a lot and it moves around each little landslide. And so we end up with this kind of wiggly fence like we've got. And we've had landslides there on and off for a long time along this front. And I asked him, I said, well, how long do you think Shoreline Park will be there? And nobody seems to know. You know, it's at about a half a foot a year. You can do the math. It's a thin park. Is that where we want to put our money? Do we love Shoreline Park so much that we're going to build a seawall to the top of the thing and backfill behind it and turn it into something like down at Palisades? That's what they did. You ever been down to Santa Monica? You see where the beach is, and they got that wall. It's about 80 feet high. We can do that if you want to spend that kind of money. We don't have the sand flow there, and much of the beauty of it would disappear as we know it today. So I wouldn't necessarily be in favor. That's just the old sea cliff Gary showed. And all this is properties, you know, essentially because we built the harbor. And the mesa is another one of these uplifted areas. We're lucky we have areas that are uplifting pretty fast. Our uplift rates are 1 to 2 millimeters per year, about the same rate as sea levels going up. So maybe we'll be lucky in that respect. This is that little, again, going back to Shoreline Park and the sea cliff and what happens. I have a picture of that landslide I was going to show you. I had a lot of interest in this landslide. I was there when it occurred. Gary showed this picture as well. And it just about caused Parks Department to hemorrhage. And I pointed out when we went out there, they're good people, don't get me wrong. They do really good work. Our city's full of lots of good people, young people, enthusiastic people, want to do the right thing. And I went out with them one day, and the city hired someone, paid them a lot of money to tell them that they should move the fence. And so I told him that the first day. I said, just move the fence. You know, there's an outhouse here. I said, I don't think somebody will be sitting on one of the stools when the next landslide occurs. When that gets closer, move it back. And I said, look at this. That's a landslide. That's a landslide. That's a landslide. It's not any bigger than that one. Since I've been in Santa Barbara, at least 3 along here have occurred about the same size as this little landslide that caused the sidewalk here to drop down. And they said, well, should we go and remove it? I said, yeah, waves will take care of that within a year. And in fact, it's pretty much gone. They may have removed it, but I think the waves took it away. Broke it up and took it away. And so then they had this great big fence here, about 6 feet high, and compared to about 3 feet along here. And they were all worried about the outhouse and some of the other stuff, maybe rightfully so. I think they're working on the stairs now. But I said in the end, I said, just get a policy. When these little landslides occur, just move the fence. And you don't need to put in a 6-foot one and kill all the vegetation behind it and make it look like it's a disaster zone. Because you go out there and look at it and say, my God, it must be something really big happening. But it was the same thing that's happened a lot. Now, having said that, it's closer to the road, and eventually there'll be a problem. You know, I've seen some places in California where the parks are right about up here along the roads in some places, and that eventually will happen. But if you want to keep the character of the park the next 100 years or so, the way to do it is move the fence. And not get into a conniption about trying to spend hundreds of thousands and millions to fix it. Because parks to me are one place where values of scenic things are high. Okay? And so that's good. Here's a little bit of that slide. All this stuff fell down in the sea. And I think it's all gone now. Here's a bit of the fence, but they built this 6-foot fence, just built a little one. It hasn't really, the ones I've seen there before, when they move a little bit, they don't necessarily tend to move again right away. And it's been a few years and there's no more cracks. But you can watch, I mean, once you get attuned to this, you can pick out, and when it starts to happen, you can move the fence even in advance. But you don't have to, you know, it's gonna happen again, of course. And so some sort of long-term policy from parks, of our coastal parks, would be useful. Some guidelines, so when the present people leave, they have something they can read. Oh, this is what we're supposed to do. We have a little landslide, we'll move the fence. We won't pay somebody $200,000 to tell us to move the fence. Along the coast, people have built all sorts of soil cement. This is near Shoreline Park, and pipes. There are things technically you can do to slow down the rate of retreat. I actually know this guy. He lives pretty close to where I have a house, and I said, get rid of the eucalyptus trees. They're really heavy. And also try to plant indigenous plants close to the thing. Don't water them. Getting the water off the sea cliff is a good thing to do. But even doing all that is still going to continue to erode. It's a very high sea cliff. There's not a lot you can do about it. Removing big trees along the top can be dangerous too, and you think about it, you're loosening things up, so you have to do things carefully, but basically controlling drainage. The harbor is another area. We don't want, there's not much beach here. We really don't want the boats to float out of the harbor. You know, as the sea level rises a few feet during big storms. And so eventually we're going to have to, I would guess our values will be that harbor is kind of center case of downtown. It's going to be defended somehow. We're going to have to put money there. And because right now waves wash over this thing. Can you imagine with 3 feet higher, you know, these people would be swimming. Today we bypass the sand, we take it from that sand spit and put it on the beach and nourishment. So beach nourishment's kind of a nice way to go. I once recommended for Goleta Beach, they were talking about spending $10 million to save the beach and the park. So put that $10 million in the bank. Okay? Draw on the interest for a few years, and when these El Nino years come along, you'll have some money, use it in beach nourishment, fix it, and put your money back in your bank, and you could probably fix it forever. Until I realized that sea level is going to rise 3 feet. And then I said, well, maybe not, you know. Maybe with sea level rise, that changes the formula of how we think about beaches. I never thought of them as permanent, but I didn't think of them disappearing in 100 years.
The problem is there's no interest on your bank account.
That's no interest today either, that's right. That's absolutely true. That's back at the time when we actually had banks that paid interest. And then so this, I was going to go, when we built the harbor, it cost a lot of erosion. So whatever we do in our values and how we decide to deal with our erosion problems from a littoral cell standpoint, for that I mean all the sources of the sand, its flow along the shore and where it goes out the submarine canyons, we got to treat that as a system or we'll end up doing things like we did this before in some areas, having very high rates of erosion down from structures. We've developed, some places developed the so-called E-zones, and that assumes you know, when this first came out, that you knew the rate of erosion, which we don't usually know, though we can measure it like Art. There are many people like Art Sylvester that go out every year, faithfully measure this. I've tried it with LiDAR and other methods. It works okay, but it's not near as good as actually getting on the ground data. But you can't do that everywhere. And they never really built into this thing the sea level rise we're talking about. We do know if you put structures in that tends over time, the beaches often get narrower. There's lots of examples of this. Not always, but lots of examples. And so that's something to think about. The sand flow, Dave Ravel and Gary Gregg, you guys have worked on that. This idea that massive amounts of sand is moving along the shore, but it's not constant, it's variable. Some years you got lots of sand, some years you don't have hardly any. And so when you don't have much, the beach erodes, and then a bunch more comes down, and we feel good again, and then it goes away, and we start to panic again. So we're not planning for these long-term ebbs and flows in our littoral cell. This is just one example of a simplest type of seawall you could possibly have down near Summerlin, and it's just a few feet of rocks, and you can see the beach is relatively narrow here compared to here. And that kind of thing's pretty common. Well, first of all, the rocks take up a fair amount of the beach by themselves, right? And secondly, if you believe in some of the models, they can reflect the waves, and Jenny back here has worked on things that birds and things don't much like narrow beaches, and so we change the ecology of beaches when we put these structures in. So, go on to this. Anyway, so with rising sea level, I really feel it'll be about science. But before the science, what choices does science provide to control sea level or coastal erosion? And what does the values clarification add to the tough choices? So we can decide reduce CO2. We should do that for lots of reasons. Land use control, technologically hard fix, soft fix, like beach nourishment, or some mixture of that, as long as we consider the whole cell. But where are our values? Before we get to this, we've got to go through this exercise. Because otherwise, we're just going to move from crisis to crisis. Oh my God, Goleta Beach is eroding again. Santa Barbara Point had a landslide. Isla Vista had a landslide. What do we do there? So we go out and we just fix that. Now's the time when we know in the next decades kind of what the changes are going to be. We should be setting up a sort of values clarification so that we don't have to face this. Instead of being so reactionary, we can kind of be proactive about it and say, well, this fits into our long-term plan. It's at Shoreline Park. We decided we're going to move the fence. Okay, this happens at this particular place. We decide we really need to fix that. So let's spend the $10 million or whatever. Unless we think we're going to have so much money we can fix everything, in which case we could lose everything. So there's something to think about in all of these things, and I think science and values is at the heart of it. Okay, thanks a lot.